Okay, let's get into it. We're going to unpack this incredible mix of uh, noise, emotion, and pure technology.
Mm.
Because rock and roll isn't just about attitude. When you get right down to it, it's a story of engineering.
It absolutely is. It's about solving problems. And what's so fascinating is that the original goal of rock, just to be loud, was, well, it was impossible at first.
How so?
Well, the first rock musicians were using hollow body guitars, basically acoustic instruments, and the second they tried to crank up an amplifier.
You get that horrible screaming feedback.
Exactly, that high-pitched squeal. The body of the guitar would literally vibrate along with the speaker, creating this awful feedback loop.
So they were fighting the laws of physics. They wanted this massive arena-filling sound, but were stuck with parlor room acoustics.
Until, that is, a couple of inventors came along. We're talking about Leo Fender and Les Paul. They looked at this problem and completely changed the game.
By creating the solid body electric guitar.
Right. They figured if the body doesn't have a hollow space to resonate, it can't feed back. It was almost a simple idea, just a plank of wood to hold the strings.
And that let musicians finally turn up without the whole thing self-destructing.
Precisely. But the real magic, the thing that turns that vibrating string into an electrical signal, is the magnetic pickup.
Yeah, let's break that down because it's kind of the heart of the whole thing.
Okay, so think of it like a tiny generator. The pickup itself is just a set of magnets wrapped in super thin copper wire.
Okay.
And because the guitar strings are made of steel, when they vibrate over that magnet, they disturb the magnetic field.
And that disturbance.
It creates a very, very small electrical current in that copper coil.
So there's no actual sound yet, just this tiny electrical signal running down a cable.
Exactly. That's the raw ingredient. That's the signal we're about to shape and amplify and turn into music. It's the very start of the chain.
And while the guitar gets all the attention, the real foundation of a rock song is the rhythm section.
Absolutely. The architecture of the song. And that begins with the electric bass.
The bass is so essential. It has these much thicker strings, which is why it creates those really deep, low tones. It's the glue, really.
It is. It locks the melody, the chords into the physical groove from the drums.
And that interaction, that lock between the bass player and the drummer, that is the rhythm section.
If they're tight, the song just drives forward. If they're not, well, the whole thing can fall apart.
And the drummer is the engine. A standard drum kit is actually a pretty complex setup. You've got the bass drum for that deep thud you feel in your chest,
The kick drum?
the sharp crack of the snare drum,
Yeah.
and all the different cymbals to keep time and add accents.
But rock didn't stop there. The sound got way bigger when electronics entered the picture. I'm talking about synthesizers.
Okay, so what's the key difference here? A synth isn't just a fancy keyboard.
Not at all. A guitar or a piano creates sound with a vibrating string. A synthesizer creates sound completely from scratch, using electricity.
How does it do that?
It starts with a component called an oscillator, which generates a pure, raw electrical wave. Think of it like a constant electronic hum.
And then you shape that hum.
Exactly. You run that wave through filters that let you carve away frequencies, kind of like a sonic sculptor. You can make it sound bright or dark or muffled.
So you start with a rich sound and just take away what you don't want.
That's the basic idea, yeah. It's called subtractive synthesis. But then you have the sound that really defined the 80s, those bright, metallic, bell-like tones.
Oh, yeah, I know that sound.
That often came from a different technology called FM synthesis. It's a lot more complex, but basically you use one oscillator to mess with the frequency of another one. It creates sounds that could never exist in the acoustic world.
So you're creating a sound that was physically impossible before that technology existed.
You got it. Okay, so let's go back to that tiny electrical signal from the guitar. It's way too weak to do anything on its own.
It needs power.
A lot of power. And that's the amplifier's job. The amp is the muscle. It takes that tiny signal and boosts it exponentially, making it strong enough to physically move a speaker.
And this is where guitar players get really passionate, right? The whole debate over the circuitry inside the amp.
Oh, yeah. The big one is vacuum tubes versus solid state. Classic rock amps use these old school glass vacuum tubes.
And they're still prized today, which is wild. Why? What's so special about them?
It's about how they fail. When you push a vacuum tube too hard, it doesn't just cut out. It starts to compress and distort the signal in a really pleasing musical way.
So it adds warmth.
Exactly.
Yeah.
It adds these nice harmonics and sort of rounds off the sharp edges of the sound wave. That's the classic warm, sustaining tone of a band like Led Zeppelin. Early digital amps, by contrast, just sounded harsh and brittle when they were pushed too hard.
So the imperfection of the tech is what actually makes the perfect sound.
In a way, yes. So once the signal is strong enough, you sculpt it with the amp controls gain, which adds that initial distortion, and then bass, middle, and treble to shape the tone.
And then that supercharged signal finally gets sent to the speakers, often in those huge stacks you see on stage.
Right. And those speakers are what finally convert that electrical energy back into mechanical energy sound waves moving through the air and hitting your ears.
This is where it gets really fun for the player, though. Effects pedals.
The secret weapons.
These little boxes that let a musician completely transform their sound just by stomping their foot.
They're basically miniature sound-modifying computers. Take the most famous one, distortion.
The sound of rock.
It takes that warm tube overdrive we talked about and just pushes it to the absolute extreme. The pedal circuit aggressively clips the sound wave, squaring it off.
And that squared off wave is what gives heavy metal that gritty, angry, buzzing sound.
Exactly. Then you have something totally different, like a wah-wah pedal.
Which makes the guitar sound like it's talking.
Yeah. It's a filter that you control with your foot. As you rock the pedal back and forth, you're sweeping a narrow band of frequencies up and down. It creates that very vocal wah-wah sound.
And then there's delay, the echo effect.
Right. A delay pedal digitally records a tiny piece of what you just played and then plays it back a few times. It can turn a single note into this huge atmospheric landscape.
And musicians chain these things together, right? On a pedal board.
Yeah, and the order really matters. The output of one pedal becomes the input for the next. You can build this incredibly complex, unique sonic signature.
Okay, so we have the instrument, the amp, the effects. But to really understand a rock concert, we have to talk about physics, the sheer volume.
Right, sound is just waves in the air. We measure the pitch of a sound, its frequency in hertz. But rock is all about volume, and volume is amplitude.
So a bigger wave means a louder sound.
And much louder sound. And rock engineering is all about making that wave as big as possible to create a physical, high-energy experience.
And different frequencies act differently. This is key. Low frequencies from the bass and the kick drum have really long, slow waves.
Which is why you don't just hear them, you feel them in your chest. They're powerful pressure waves.
While high frequencies, like from cymbals, have short, fast waves. They give the sound clarity, but they don't travel as far.
And managing all of that in a giant arena is a massive challenge. That's what the PA system, the public address system, is for.
To get the sound to the people in the very back row.
And to do that, they use what are called line arrays. Those huge columns of speakers you see hanging from the ceiling at a concert. They're angled very precisely to make sure the sound is clear everywhere in the venue.
But what about the musicians on stage? They have to hear themselves over all that noise.
Traditionally, they use stage monitors, those wedge-shaped speakers on the floor pointing back at them.
But that just adds more volume to the stage, which can make things sound muddy.
And
And it's terrible for your hearing.
it is, which is why almost all major performers now use in-ear monitors.
Like custom-molded earbuds.
Exactly. They solve two problems at once. They block out the dangerously loud stage volume to protect their hearing, and they deliver a perfect, crystal-clear mix of the band right into their ears.
Beyond the sound, though, a modern concert is a visual spectacle, and it's all driven by tech.
It's all synchronized. You have massive LED screens, moving lights that can change color and position instantly, lasers, smoke.
Pyrotechnics, the sparks and flames.
And all of it, the lights, the video, the pyro, is controlled by a central computer. It uses signals like timecode to make sure every single visual effect happens at the exact right moment in the song.
It turns the concert into this completely immersive event.
Yeah. Okay, let's shift gears from the stage to the studio. The recording studio is this super high-tech controlled environment.
Full of sensitive microphones and those enormous mixing consoles with hundreds of knobs.
And that's where the engineer balances everything. But the biggest change in the last few decades has been the digital audio workstation, or the DAW.
The computer software.
Right. The DAW lets you see the music as visual waveforms on a screen. You can cut, paste, and edit sound with surgical precision. It's an incredible amount of control.
And that technology enables multi-track recording.
Which means the band doesn't have to play the song perfectly all at once. The drummer can record their part one day, the guitarist the next. A singer can record their voice 10 times and layer them to sound like a choir.
And after everything is recorded and mixed, there's one last step, right? Mastering.
Mastering. It's not mixing, it's the final polish. The mastering engineer makes sure the song sounds good on any system, from
Okay.
tiny earbuds to a huge club system.
They also make sure it's loud enough to compete with other songs, that whole loudness war thing.
Right. For years, everyone just tried to make their tracks louder and louder. Now, streaming services have started to normalize the volume, so if you make your track too loud, the platform just turns it down. It's actually bringing dynamic range back into focus.
But what I think is most important about modern tech is how it's democratized everything. You don't need $1 million studio anymore.
Not at all. A basic laptop with a good DAW can produce professional quality music from a bedroom.
And you have software instruments that can create incredibly realistic backing tracks. You can program a full drum kit or a string section without hiring anyone.
And then there are plugins. These are little bits of software that can imitate super expensive vintage studio gear. You can make a $50 microphone sound like it's running through a $10,000 preamp.
It's amazing. And because everything is digital, you can collaborate with people all over the
You
world.
just send the files back and forth. A guitarist in Japan can play on a track with a drummer in Brazil. The borders are gone.
And the way we listen has changed so much too. From vinyl records, where a needle literally read physical grooves.
To cassette tapes, which finally let us take music in the car. Then CDs gave us that clean, hiss-free digital sound.
And now, it's all about streaming. Complex algorithms compress the music so we can get it instantly on our phones.
So with technology always changing, what's next for rock?
Well, we're already seeing AI used as a creative tool, helping musicians come up with new chord progressions or ideas.
And the instruments themselves are still evolving. People are making guitars out of new materials like carbon fiber to make them lighter and more stable. And wireless tech on stage gives performers total freedom to move around.
It feels like the spirit of rock has always been about taking technology and just pushing it, finding new ways to be loud and innovative.
Technology doesn't just enable rock music, it actively shapes where it's going to go next. It ensures there will always be new tools for the next generation to find a sound that is completely their own.
The second a new piece of tech comes out, you can be sure some guitarist somewhere is already trying to figure out how to break it to get a cool new sound.
Good luck with your studies.